Hi there. Welcome. My name is Michael Comer. I'm the marketing manager here at McGraw-Hill, and I would like to welcome you tonight to the webinar on teaching the Common Core State Standards for Mathematical Practice, the standards focusing on mathematical communications. I just want to begin by saying that you're all probably familiar with the Common Core State Standards, as they are a set of research-based mathematics standards that span from kindergarten through high school. These standards are closely aligned with the college entrance requirements and career expectations of the 21st century, and the standards promote rigorous content with a focus on building computational fluency in the early grades, while instilling higher-order thinking skills in all students as they progress across the grades and as they mature as learners. The Common Core State Standards include two different types of standards. There are the content standards and then the mathematical practice standards. The standards for mathematical content are organized by grade level in grades K through 8, and then by content or concept in high school. There are also 8 standards for mathematical practice. These apply across all grades, K through 12, and are based on the process standards from NCTM, which includes the strands of mathematical proficiency from the National Research Council's report, Adding It Up. They also include the broad expectations or attitudes, such as working towards accuracy, using abstract reasoning, modeling, and persistence. The mathematical practice standards are intended to be interwoven with the content standards. And if the content standards are thought of as the what of the curriculum, then the mathematical practice standards should be considered as the how and the why. This series of workshops will focus on the standards for mathematical practice, especially as they apply to the K-8 classrooms. But before I begin, I just want to get a sense of where you are as an audience or from. And so I'm going to open up a poll and ask you first, where are you from? Please feel free to join in. As I get the poll ready here, you'll see it come up. And the poll is open. All right, and so I'll just share the poll with you so that you can see where you are from. So the majority of you are a nice mix of the Midwest and the East, and we have friends from the far West Coast also. So thanks for joining. I have one other poll that I want to ask you about too, and that would tell me what grades do you cover. So I'm going to launch this poll. If you just give me an idea of what grades you cover or students you service. And again, I appreciate that. And let me just share with you so you can see that the majority of our attendees this evening are from the elementary grades, with a mix of middle school and high school. And I'm curious about those that are in the other category as to probably being attendees. So I want to say thank you for sharing that, because this helps me to tailor the conversation this evening and provide examples from the grades that are best represented here tonight. So as we move forward in the presentation, I just want to say that we've organized these 8 mathematical practice standards into a 4-workshop series. And as we look at those practice standards, there are some inherent relationships among them that allow them to be organized in a way that makes them easier to think about. And so, for instance, tonight's workshop is on the mathematical communication skills, which include those standards 2 and 3. These are the skills that students must have in order to think mathematically and to communicate that thinking to others, in addition to being able to evaluate the reasoning of others. The last session we had was on the mathematical mechanics, and those are standards 4 and 5, that refer to the working with models and tools that are useful for solving problems. Standards 7 and 8 will be coming up in January, and these will address the higher order thinking skills, or the intuitions that students develop as an awareness as they move beyond the simple computations in the lower grades in order to really understand how the math works. They must become more effective and efficient in their application of computation in order to address the more deeper understandings of the key concepts. In other words, 7 and 8 refer to the abilities of students to become more adept at becoming efficient problem solvers. And then lastly, standards 1 and 6 are those overall mathematical habits of mind that we desire to instill in all of our students. These are the dispositions that students need to learn early and use regularly in order to successfully apply them to all of the other practices and to navigate the challenges that real-world problem situations present. Tonight, we are going to focus on Standard 2, Reason Abstractly and Quantitatively, and 3, Constructing Viable Arguments and Critiquing the Reasoning of Others. There are 3 primary workshop objectives to this series, and the first is just to become familiar with the commonalities found within these 2 mathematical practice standards. The second is to explore ways that you can incorporate these practice standards into your lessons as part of your instructional routine. And the third is to take a quick look to see how McGraw-Hill's MyMath has incorporated these practice standards into their lessons. But as we begin, let's just think about what is mathematical practice. Mathematical practice may be thought of as the goal or outcome that students will achieve as they strive ahead in their work. The practices should be a pervasive way of thinking and doing that percolates throughout the students' thinking as they work to solve problems, not only in mathematics, but in a broader sense in all areas of their lives. In essence, it is the ultimate goal of creating good thinkers and problem solvers. And to do this, it requires that students be able to think, read, speak, and write clearly using mathematical language and symbols. It also includes the student's ability of using logical and sound reasoning when approaching unfamiliar and non-routine problems. It asks them to attend to a degree of precision in the details of solving problems, including the details of mathematical calculations. And last, it requires them to have a flexibility to evaluate a problem and select from a multitude of strategies those that they feel comfortable or best suited to solve the problem. In other words, it is important to reflect on the concept that the practices are not a set of discrete skills or problems that children should encounter in the course of their mathematics instruction, but are really the attitude and personal disposition or temperament that they should bring to the issue of solving problems. It should be pervasive throughout the classroom environment, created by the teacher in order to develop these lifelong and positive habits of mind in all students. And so as we think of that, how do we do the mathematical practices? This is what I find teachers are asking most. How do I know that I am teaching these? And if we want to think about that, we need to consider then that the practices are in large part a reflection of the classroom learning environment that the teacher actually creates. It is what the teacher models, and it cuts across all of the disciplines. And to do that, teachers need to do it intentionally and purposefully as they focus on these 3 areas: embedding problem-solving routines as part of the ongoing classroom instruction, and then connect it across the multiple subjects for greater coherence. It is what the teachers do to foster a classroom culture of learning that encourages respect for discourse and discussion among the peers in the class. And third, it provides an environment where opportunities for mathematical tasks vary in difficulty, context, and complexity. So tonight, we're going to look at two of those standards. Standard 2, reasoning abstractly and quantitatively. The mathematical proficiency here involves understanding the meaning of numbers and how they relate to each other in problem situations. Being able to extract or decontextualize the numbers from a problem to perform computations is an important skill. The example here illustrates how to remove the quantities to decontextualize them in order to perform the operation. Ed wants to share 18 grapes equally among himself and 2 friends. How many grapes will each person receive? As you notice, the computation statement at the bottom, 18 divided by 3. Decontextualizing the problem pulls the numbers from the problem and presents them in the way that identifies what mathematical operation will occur. The example here illustrates the removal of those quantities. However, it is only half of what the students need to do because they must be able to relate those numbers back to the problem or contextualize them so that they can verify their work and identify the appropriate units of measure as a way of checking their answers within the context of the original problem. So 18 divided by 3 equals 6. But the answer is 6 grapes. Each person will receive 6 grapes. As we look at standard number 3, constructing viable arguments and critiquing the reasoning of others, this addresses the need for students to build and defend a justification for their mathematical thinking. At the same time, they must be open to considering the reasoning of others. In the early grades, students begin building arguments to support and defend their own thinking. They develop an awareness of others, and their emerging social abilities are important skills to practice as they learn to listen to and evaluate argument of others. Demonstrating this process by teachers is important through such activities as thinking aloud, which allows students an opportunity to see teachers as a working model for solving problems using mental steps as they think through the course of a solution. While none of the mathematical practice standards stand alone from the rest, these two standards are particularly intertwined. Keep an eye out this evening for the interconnectedness of these two standards as we look at some examples moving forward. In this case, I want you to think for a minute of your own classrooms, where you've been working on multiplication tables and various ways to calculate the product of 2 factors. And then you come across a problem like this. If there are 12 1-cent stamps in a dozen, then how many 4-cent stamps are there in a dozen? How many of you immediately thought 3? Well, in order to reason, we need to think about the context of the problem and not just the immediate thought of doing the computation. We would want to focus on the numbers presented, but did we take time to think of what the problem was actually asking? The question was, how many stamps are there in a dozen? The value of the stamp is not important because we were not asked for the cost of the stamps or to make an equivalent value of stamps equal to the first set of data. We were not asked how many 4-cent stamps are equivalent to 12 1-cent stamps. Our understanding of the language of the problem is critical, but its emphasis is important of using reasoning to solve the problem. So how many 4-cent stamps are there in the dozen? Well, there's 12. Let's try another example in which I'll share some student work, and I'm going to ask you to provide an answer to this question, so please be ready to respond. Here on the screen, we are given a 10 by 10 grid. Notice on the grid that the numbers are placed in each section of the grid, beginning in the upper left-hand corner with a 1, moving across the top row, 2, 3, etc., identifying 10 squares on the top. the numbers are arranged sequentially around the grid and then go down the side beginning with 10, 11, 12, and so forth. So looking at that grid, you'll see that there is a star placed just below the number 1. Without counting, what number should be in the box with the star? And I am going to poll you for your answer. What answer do you think belongs here? Now I'm asking you, remember, without counting, what number do you think belongs here? 42, 40, 37, 36, or none of these? And the poll is open. All right, I'll close the poll for a minute. All right, now before I share the answers with you, what I just want you to think about is some student responses in solving this. Here's an example of one student's work, Susan, and she wrote the answer was 40. And her reasoning was that there are 10 squares on a side, and there are 4 sides, so 10 times 4 is 40. I see that some of you may have thought the same, as 19% of you answered 40 as an answer. Well, here another student, Tina, had similar thought, but came up with a different result. Her answer, she said, was 39. And her logic was that there were 10 squares on a side, there were 4 sides, and 10 times 4 is 40, but the star is 1 square less than the corner, so it was 40 minus 1 equals 39. Which student work is accurate? Ask yourself why or why not. And as you think about the student response, what questions would you like to ask Susan or Tina in order to better understand what their reasoning was as they were solving the problem? What I'd like you to do in the webinar for a moment is to examine your own thinking as how you solved the problem and analyze what your thoughts were, your logic, as you were working through the problem. Now, we can go back to the original problem and think about where the star is located. And I'm sure that there are a variety of strategies you can use. Let me just share 2 of those with you. Following the sequence of numbers across the top and then down the side, you'll notice that the square in the bottom left, at the bottom right-hand corner is 19. Why is it 19 and not 20? And as you think of that, notice that the square in the upper right-hand corner is already occupied with the number 10. So each row below that, then there are just 9 spaces. We had 10 spaces across the top, 9 spaces down the side. So if this continues across the bottom, how many spaces are there across the bottom? Another 9 brings us to 28. How many spaces going up the side to the star? Is 8. And so as we think about that, it's 10 plus 9 plus 9 plus 8 is 36. So it's one way to think of solving the problem, is thinking about the location of each square. Another way of solving that for a solution may be to think again that where the star is located and recognizing that there are 10 squares across the top row and there are 10 squares across the bottom row, which leaves how many squares between the 2 rows? and that would be 8. And so that there's 8 squares on the right side of the grid and 8 squares on the left side of the grid. And so the activity then becomes 10 plus 10 plus 8 plus 8 is 36. It is this kind of activity that helps children begin to think of number in different ways. As we were looking at this problem, you might want to just add an extension and ask students, so if we were to look at this grid again, where 36 is located, where might you think 100 would be on this grid? All right. To the center, that's correct. And it would be to the center. Do you think it's either A, B, C, or D in this case? And again, think to yourself. All right. Does the pattern to complete the squares as we work around the grid, notice as we go from one corner to the next, what the quantities are. We'll go around 2 more times, once, twice. I'm sorry, we'll go 1 more. What do you notice about the pattern of the numbers that are forming at the end of each of the arrows? You notice from 10 to 44 to 70, what kind of numbers are these? 36 to 64, what kind of numbers are these? 28 and 58. And then 19, 51, and 75. Is there something similar and something different about those rows of numbers? And what you may have realized is that where I don't think 100 is, it's probably not in C. If I were to ask students why, because they might say that they recognize a pattern here of odd numbers being in this corner. So where might A, B, and D, there might be positive numbers which might represent 100. And then students can continue seeing if their conjecture holds true as we add more numbers to the grid. Where now do you think 100 will land? And they count through, they can find that it was D. All right? The idea here is as we look at these kind of problems, that the standard mathematical practice to reason abstractly and quantitatively is that we want students to be able to make sense of quantities and make sense of the relationship of numbers in problem situations. Students should be able to at first analyze a given situation and abstract the numbers from the context of the problem. They should then be able to represent it symbolically and manipulate those numbers and symbols, and then be able to use the context of the problem to determine what operations are needed in order to solve it. And lastly, the quantitative reasoning includes creating some representations of the problem. They need to consider the units involved, attend to the meaning of the quantities, and use different properties of operations and objects. Well, what does that mean for students? Certainly in the early elementary grades, this is somewhat understood as what students should understand as the meaning of number and how they relate to other numbers in the problem context. In other words, to establish meaning for the numbers. They should also be able to correctly perform the computations that the problem asks and verify their work, particularly paying attention to appropriate units of measure where applicable. And then lastly, students should be able to frame their answer within the context of the problem. So what does this really mean as we're thinking about it? Well, in the early elementary grades, what we're asking students really is, can they identify a known and the unknown? or the missing quantities. And to help them with this difficult concept, students should be provided with ample discussion opportunities about the unknown quantities. Using part-whole diagrams in which one part and the whole are provided helps students to identify the unknown or missing quantities that are needed to solve the problem. And then within the problem, it's important for them to think of the values that they're dealing with. They should be able to ask, what will we need to find? Will it be a greater number or a lesser number? And then as students consider the operation that they choose to embark on, they have to ask themselves to share, how do we know what to do? And then what numeric representation do we write? And so as we encourage students to then write and speak about the way they put the problem together without the context of the problem, it's important for students to stress that using the correct mathematical language and units of measure are an important part of the problem-solving process. And finally, to have students consider their answer within that context of a problem to make sure that their answer makes sense. So they should ask themselves, does this make sense? What I'd like to do is share with you a little video of a first grade classroom in which the practice is being applied. What I would like you to notice in the video is how the teacher includes several instructional strategies here as she moves students from understanding the word problem into making a numeric representation of it. Watch how she first decontextualizes the problem to help the students identify what it is they are looking for. Identifying what operation they are looking to perform, she then moves them to thinking about the numbers in the problem. And at the end of this short clip, you'll see how she directs them back to putting the problem in context by writing a numeric statement of the problem. Let's see this short clip.
Apples. Jordan picked one more apple. How many apples did Jordan pick? Do you think we should add or subtract? How do you know? Can you take a look here? Can you circle for me to tell me what I should, why I should add? One more apple. That tells me I should add. So I know that I started with 7 and I have one more. So now what we're going to do is act it out. I need 7 apples. So I need 7 of you. Let's see. So here's Luke. Here's his 7 apples that he picked. Jordan has one more. Jalen told me I need to add. So what do I need to do? Zola? I need one more. Zola, come on up. So if I have 7 apples and one more, 1, 2, 3, 4, 5, 6, 7, plus one more makes, Haley? 8. 7 plus 1 equals 8. Thumbs up, do we agree? All right, good job, thank you. Have a seat. Number 1, let's write a number sentence. So our number sentence for number 1 is going to say 7 plus 1 equals 8.
As you can see, the teacher moves the students through the problem, helping them to decontextualize it by having them at the front. Think about that as part of the video discussion. In what ways did the class remove the problem from context? And that was by having the students model it in the front of the room. How did talking about the problem in the absence of the context help students to solve the problem? And then lastly, think about how the teacher supported students as they worked to remove the problem and then reconsider the context. So I encourage teachers as they're working on modeling the problems to think about how they are applying the, helping students to decontextualize the problem, take it out of context, make sense of it, and then repackage it or rebuild it to put it back in context. Here's another example of working on contextualizing the problem. In this example, the same classroom, I just want to say that this teacher actually then works on a problem in which they contextualize it. Notice how she has students make up stories as a method for contextualizing the problem, giving details to an open problem in order for them to better understand what to do. Watch as the teacher uses the creating a story problem as the method for solving problems here.
Here it says how you count back to find 11 minus 2. I want you guys to talk in your group about how you're going to figure that out. What are you guys going to do? So talk in your group. How can you figure that out?
What if they said, how many kids? Okay. There were 11 kids, and they put in, and 2 kids went home.
So let's pretend our cubes are our kids. So we had 11 kids. Good job, Shahir. So we had 11, and then what did they do?
And two went home.
And 2 kids went home. So take those away. How many kids are left?
So as you notice, that one thing to notice in this video segment is that as we focus on the mathematical practice of reasoning abstractly, the teacher was having the students use connecting cubes as tools to visualize the action of the word problems. And as we discussed last month in the webinar on models and tools, the cubes in this point were tools. They were the device that the student was using to help them solve the problem. The standard here that the teacher was focusing on was on helping the students to reason through it, and the tools were just a device to help them. It's hard sometimes to tease apart in the classroom the different practices because they do overlap within the context of the problem. But in this instance, it's important to notice how the teacher focused on contextualizing the problem and not focused on the using of the tools. The teacher made a conscious decision to forego emphasizing the tool in order to focus on emphasizing the reasoning aspect in the instruction. And what I'd like to point out is that this decision is important because it's easier for students to concentrate on one aspect of instruction and not to get confused with multiple purposes being thrown at them simultaneously. Making decisions on what is important in the lesson ahead of time helps teachers to identify the opportunities they desire to use for the targeted instruction of a specific practice. It's not efficient to have many problems identified with multiple and different practices in one lesson, as it can create confusion for students who are just beginning to understand the work that they are working on. We encourage teachers to have a targeted and focused opportunity to select a practice to work on for specific types of problems. So in later grades, let me just say that students need to speak mathematically about operations as they mature as learners in their mathematical work. They should represent problems both algebraically and graphically using representations such as charts and tables. And as a continuation of their contextualizing the problem, students can create graph stories as one way in which they begin to reason abstractly. I suggest as a way of helping students to begin to model and emulate that logical thinking, that graph stories are a good way to develop that. Removing the reference from a graph helps students to concentrate on the data that actually might fit the visual that they are presented with. Let me model what I mean. Here I'm going to show you a graph And I want you to take a minute to think about the types of data that could be represented here. What kind of story would you create based on this graph? A line graph in which the line on the graph rises slowly, levels off for a period of time, and then gradually declines. What type of story or data could be depicted by this graph? Explain. So think to yourself for a moment, what kind of graph is represented here? As I move my finger along the graph, as I tell my story, does it make sense? If I were to add some labels to the graph, time across the bottom, as I'm telling my story, what does the y-axis represent as part of the story? And what I'd like to do is just suggest that these are great stories for having students work with the opportunity to reason abstractly. Here are 3 graphs that are represented, and I'm going to give you 4 stories. You tell me what graph each story goes with. Here's the first one. Our school hosted a festival. The morning was rainy, and not a lot of people came. But the sun came out, and more people came. It got busy. What graph there represents that kind of story? Is it A, B, or C? That's right, B. B represents that, because as I put my finger at the beginning, people were coming to the fair in the morning, and then the sun came out and a lot more people came as the afternoon got on and it got busy. The graph rose slowly over time and then changed suddenly as time continued. Here's a second story. My parakeet never finishes her food. She eats most of it and leaves a little in the dish. Which graph would represent that story? That's right, A, because the parakeet eats her food at a constant rate, and then there's some left, and that little bit left stays for a period of time. Here's a third one. I was walking to school and realized I was going to be late. I had to run the rest of the way to be on time. No, it's not C. It would be B. Again, I'm starting out, if time was across the bottom and this is getting to school, as I'm leaving home, I'm going a distance. As time goes on, I get further away from home. And then suddenly I realize that time is late and I have to hurry. So my speed increases and I cover a longer distance in a shorter period of time. And what do you think graph C could represent? What story could you tell about graph C? Well, here's one that one student wrote. I have 2 cans of peas in the cabinet. I bought 3 more cans of peas on sale. I realize I don't eat peas. I had 2 cans. They lasted a long time. Suddenly the quantity changed in an instant, and the quantity stayed the same for a period of time. Stories with graphs are great ways for students to develop ways of quantifying and using language to describe their thinking. So let's take a look at some quick examples from the MyMath program about specific lessons in grades 1, 3, and 5 that address this standard. Notice in the chat section, we'll provide a link to download examples of these pages that will be there for you to look at. Here in grade 1, when we talked about the ability for students to reason quantitatively, that find the missing part is one way for them to reason abstractly for the early elementary student. Okay, how does the use of color in this example help students to visualize the part-whole of the quantity? And how might the part-whole graphic organizer itself assist students in describing their reasoning in finding the missing add-ins. As we move up the grades in grade 3, here's an example of the reasoning part is in question 11, which states, how could you change exercise 8 so that Mr. Daniels buys 81 brackets? Well, it would be important to look at exercise 8. Exercise 8 read, Mr. Daniels bought 9 packages of metal brackets to build some bookshelves. There are 8 brackets in each package. How many brackets did Mr. Daniels buy altogether? So as we think about the mechanics, the computation of it, we know that the students will multiply the 9 times 8. And then the question they're asked is, how could you change it so that Mr. Daniels buys a total of 81 brackets? Well, let me share with you some students' work again. Go back to Tina. Now, Tina was very interesting. She said, Mr. Daniels needs 81 brackets. In order to get 81, you need to put an extra bracket in each package to equal 9 brackets in a package, so he buys 9 packages with 9 brackets in each, and he gets 81. Tina doesn't really like to use periods, so her sentences run fairly quickly. But she had the right idea here, is that in order to get 81, she needed to do something to the packages. Susan, on the other hand, is a bit more pragmatic and probably shops at the store a little bit more with her parents. Her response was, Mr. Daniel needs to buy 9 more brackets, but he can't get just 81 because there are 8 brackets in a package, so he needs to buy extra. And then she goes on to explain that there are 8 brackets in a package, so 9 times 8 is 72. If he was to buy 10 packages, he'd have 80, which is still not enough for 81. He could buy 11 packages, which have 88 brackets, and then the 88 minus the 81 that he needed left him with 7 brackets extra. So the interesting idea that Susan was thinking that you couldn't change the package, you had to figure out what would happen in the scenario. What questions would you want to ask Susan or Tina about their thinking as they were trying to solve that problem? And then here in 5th grade, again, having students describe by using real-world examples is one way to help them contextualize a problem as they begin to think abstractly about their mathematics. So what does this mean for you and your students and your instructional strategies? Well, just remember that students need to actively participate in that mathematical conversation on a daily basis, beginning in the early grades. They will not be completely familiar for all students, so you need to model for them how that communication happens. And then as students are learning to think and speak mathematically, help them in developing their mathematical ideas by creating the stories that model the mathematics and providing some personal context for understanding the problem. I'm going to shift now to mathematical practice 3, in which we begin to construct viable arguments and critique the reasoning of others. And so what I just want to share with you is the idea of reasoning. In this one example of a farmer sells 72 eggs a day. How long will it take to sell 300 eggs? And as the student wrote, 300 minus 144, because she recognized that 72 eggs a day, she could double it, which would be 144. She subtracted that from 300 and got 156. She realized she had enough more to do another 2 days, so she subtracted that and ended up with 12. And then she thought, and she said, well, how long would it take to sell the 300? Well, it would take 4 days and a little bit, so probably around 11 o'clock on the 5th day. As we look for students being able to critique the reasoning of others and construct arguments, what I want you to do is just think about here. What is it we're looking for? That mathematically proficient students begin to understand and use assumptions and definitions as a way of establishing or defining an argument. They make conjectures or guesses and then analyze the situation. They use appropriate vocabulary in describing the situation and in describing the paths to the solution. They justify their conclusions. they communicate their ideas clearly, and lastly, they need to compare and analyze the arguments. As students do this, mathematically proficient students must begin to make the comparison of the effectiveness also. So as students mature in their ability to analyze and to reason, they get more complex or more detailed in their analysis. And again, what does it look like in the classroom? I encourage you to think about the conversations that you have on a daily basis and model, model, model. It's important for students to see as teachers the thinking process that goes on in solving a problem. And have students agree or disagree with the steps that you post. Sometimes making a conscious error is a good reason or a good way to have your students critique your work and to analyze it respectfully. Here I'm going to show just a clip from a grade 4 classroom. And what I'd like you to do here is notice how the teacher moves through the discussions with the students. The students here are working on the distributive property with multi-digit multiplication. And notice how the teacher asks the students to clarify their thinking, and then the student actually provides explanation of the work as he's doing it. This provides an opportunity for the students to hear what the thinking is going on as the student is doing their work. At the end, the teacher encourages the student to ask if the others agree. Let's watch.
Brandon, go ahead and do number 5 for us. How did you get 10 and 1? What did you do? What number did you break apart?
11.
Perfect. You broke apart the 11 to 10 and 1. Okay, what did you do next?
Multiply 52 to 10. And you get 5. And multiply 52 to 11 to 52.
Perfect.
And if you add 520 plus 52, you get 502. 572.
Want to ask your classmates if they all agree with you? Do you all agree?
Yes.
Okay, good job.
All right. So it's important to notice how the teacher's begun to get the students to ask each other if they agree, so that they get in the habit of looking to their peers for understanding and confirmation, and that allows them to develop that social interaction and that respect for each other as the conversations occur, as they develop and support both their argument and their critiquing of others. In doing that,
Brandon, go ahead and do number 5 for us.
what I just want to point out is that vocabulary is an important part of developing their ability to have that communication. So think of that the vocabulary, consider the research on the importance of developing that mathematical vocabulary. 2 is think of Marzano's work in terms of how do we position that vocabulary, that using visuals as a way, including pictures or images or colored text, and having the students create their own examples, aids in their ability to comprehend what the terms mean and helps make the learning personal. Consider here the definition of what a digit is and how the placement of place value is used. Think about what a digit is and what place value means. And as we think of those, let's look at this next activity. Here again is if I'm asking students to begin to critique the reasoning of others and to reason abstractly, this game is a great activity to help students articulate and develop the communication skills in order to talk about what they're thinking. In this particular game, the place value game, and you may be familiar with it, students are given 10-digit cards. There's 1 digit on each card. Those are represented by the numbers across the bottom here. And if you were to draw 1 card at a time and could only use it once, where would you place it on this place value chart in order to make the greatest number? So here's what we're going to do. I'm going to ask you to look at the place value chart, and we're going to randomly draw some numbers, and you tell me where you think they should go. All right, let's begin. The first number we'll draw is a 4. So as you look at the place value chart and on the other digits that are possible, where would you place the 4? In the 100 spot, in the 1,000 spot, in the 10 spot, or the 1 spot? In the 10 spot. All right, so let's put that 4 in the 10 spot. All right. And now let's see what next number we draw. A 6. All right, so where would the 6 be? Think of your reason, and how would you argue that where you're placing it is the best place to place it? What discussion, what words, what phrases would you use to help convey your thinking to someone else who would ask? And so where would you put it? Okay, we'll put it in the hundreds. All right, so now we have 640. What next number we draw is a 3. All right, where would you place the 3? In the thousands or in the ones? What are you thinking, and how would you express that thinking to someone else? Would you place it in the thousands? Is that the place? I think in the thousands. Or is it no, because there are more numbers greater than 3, and so I would place the 3 in the ones column. All right, so let's put the number in 3 in the ones column, and let's see what last number we draw. Oh, we draw 1. So we ended up with 1,643. But in some cases, if you had placed the 3 in the 1,000 spot, you would have done better. But the idea here is not who wins the game, but in the providing of the discussion in working through the examples. And here's one more example I'll share with you tonight as we begin to wrap up, is to look at this problem, and I'm going to ask you in a poll to choose an answer. Look at the problem here. We want to be like Trump. You're playing a game called Rental, and while playing the game, you own spaces A, B, and C. If you were to put a hotel on any one of these spaces, the rent would be $1,000. Player 1 and player 2 will spin the spinner and then move that number of spaces. As you look at where player 1 and player 2 are, and where spaces A, B, and C are, where would the best place to build your hotel be? In space A, space B, or space C? And what I want you to do is to think about that in terms of what the opportunity is. So let me open the poll. And the poll is open. Think for a few minutes before you respond. Where would you like to build a All right, let me close the poll and share it with you then. An interesting result is that about a quarter of you thought space A, and about 3/4 of you thought space B, and yet no one thought C. And so it would be interesting then to have you create or defend why is your choice better. All right, and so as students work through that, and as you think about where you've placed it, if I was player 1, what would be the choices to hit the spaces here? Well, a 2 or a 3 would give me a great opportunity. So if I'm player 1, 1, 2, or 3, I have a great chance to land on A. Player 2 on its own has a great chance of throwing a 2 or 3 also, a 2 or a 3. So A or B would be ideal spaces, but why is one better than the other? And so I'm going to leave you with that thought as you begin to think about that. Where would I place that, and what would my argument be to justify why I selected that? And the nice thing about this kind of activity is it's not necessarily a right answer. It's about the probability and the odds. 3, as you see in the spinner, has a larger area. 2 is about a quarter of the spinner. 1 is a quarter of the spinner. As you look at 4, it's about 1/8 of the spinner. And so the odds are it's a great activity if you want to try it and have students actually work it out, create the board, do the spinners, and see which one comes up most. Is there a statistical response that would justify what their answer is? So in moving forward, I just want to share, I'll skip this problem for a minute, and just go back to some examples for my math. Again, thinking in grade 1, we have the, these are going to be posted in the chat box. So if you're looking for the example pages to look for, you'll find them there. Is it easier or more difficult for students, do you think, to create a viable argument in a problem that does not have a real-world context? Again, think of that. Is it easier or more difficult? That sometimes having a context for a problem makes it easier for them to understand or create an argument. Sometimes I think the context makes it more difficult if the student can't relate to the context. Putting it their own story to it makes it more personal, and gives them something to reflect on that is more meaningful to them. Here's a good example in grade 3. How does this problem get students to develop an argument? And when they're looking for which one doesn't belong. And then in grade 5, again, having an error and looking for an error is a great way for students to begin to identify what's wrong, articulate why it's wrong, and then provide the correction for the solution. Are great opportunities for them to develop those communication skills essential to meet the practice standards number 2 and number 3. So as we begin to get ready to close tonight, what I want to do is just share with you a summary of our time this evening. The 2 standards tonight emphasize the importance of developing strong communication skills in your students, and that those strong skills are centered around their ability to reason and to articulate their thinking into strong, viable arguments. Modeling mathematical discourse and engaging students in discussions on a daily basis builds student confidence in both their ability to speak mathematically and to apply their understanding of the math to new and non-routine situations. It's important to remember that the vocabulary is an important aspect of helping them to develop and nurture their communication skills. And lastly, as students create and defend their arguments and critique the reasoning of their peers, they need to focus on their ability and their social interactions, being respectful and mindful of other people's ideas and opinions. And this helps to boost and promote their social interaction with each other, their respect for each other, and also their confidence in being able to articulate what their belief is. So I want to end tonight by saying thank you. Thank you for taking the time as we get ready for the holiday to share it with me this Tuesday evening. Our next session will be on January 22nd in 2013, and it will be focused on practices number 7 and number 8, the ones which we identify as encouraging critical thinking. Visit us at mheonline.com edX for a copy of this presentation if you wish to see it. And if you wish to contact me about any aspect of the webinar tonight, please feel free to use the SEG webinars at McGraw-Hill.com address. I'm Michael Comer, Marketing Manager for McGraw-Hill. I want to thank you for spending time with me this evening and wish you all a very nice holiday. Thank you very much.